Today in this video we'll see how HTTPS works, which basically is how the communication between a web browser and the web server is secured. And the second thing we'll see is what is certification authority and how it is signed. So basically you can compare this with a Oracle certification. Say you're a Java developer and you want to identify yourself to the world that you are a Java developer, and to do that you have to get certified from Oracle. So basically what you'll do, you write an exam and get it certified from Oracle. So the same way this mechanism works. What basically web server does is, web server generates a certificate with the public key and the private key and asks certification authority to sign it, so that the web server can say to the world that whoever is communicating with the web server will be secured. We'll see how that works in future slides. And the third thing is self-signed certificate. So basically what happens is, if you want to get your certificate signed by certification authority, then you have to pay for them. So basically what happens is, if your application still is in development stage, there is no point in going for certification authority and paying for them to get your certificate signed. So what we'll do is, we will mimic certification authority within our control. I mean to say, we'll write our own certification authority and we'll use that signed certificate from certification authority which we have created to communicate through HTTPS protocol. So basically this is your own certification authority, and it can be used only in the development environment or in testing environment. If you want your application to be secure in the production environment, you have to pay for the certification authorities and get it signed. Okay, we'll see in detail how it works. So the fourth thing is SSL, secure socket layer, and the fifth thing we'll see is TLS, transport layer security. So let's deep dive into each point and see how this works. First we'll see how HTTP works. In this scenario, the web browser sends a request to gmail.com, Gmail web server, and asks for some information, and the web server gives back the information requested for. Note that the communication between web browser and the web server is not encrypted here, so anybody can come in between, any hacker can come in between and hack the information or any sensitive data here. So to solve this problem, HTTPS was introduced. Now we'll see how HTTPS works. So left hand side is web browser and the right hand side is web server. First we'll see how web server works. So what web server does is, it generates a certificate which contains one public key and one private key. Here green color key is public key and the red color key is private key. So once the certificate is generated, it asks the certification authority to sign it. So now what certification authority does is, it signs this certificate, and once it is signed, so whatever the communication between the client and this web server will be considered as secure. So now the certification authority has signed this certificate and our web server has a valid certificate with it. Okay, now coming to web browser. So when you install a web browser in your machine, it comes with list of trusted certification authorities. Okay, what I mean by trusted certification authorities is, as I said earlier, there are a lot of certification authorities present out there in the web. So basically, which are all the commonly used certification authorities list will be already present in the web browser when you install in your machine, so that if the browser communicates with any of the web server and that web server certificate is signed by any of the certification authority listed in this web browser's list, then the browser can have a secured communication between the browser and the web server. We'll see how it works now. So now the browser asks some information to gmail.com. It sends requests to gmail.com. Then the web server sends back the signed certificate to the web browser. Okay, so that certificate contains a lot of information like this certificate is valid from and valid to, and the public key information. So once this certificate is received to the browser, then the browser checks. So whoever signed, the certification authorities signed the certificate, is there in my trusted certification authorities list or not. As you can see, I have used Google Trusted Services as my certification authority. Then the browser checks in its list. Yes, Google Trust Services certification authority is present in my list. So now what browser does is it generates another key called shared key, so which has to be shared with the web server, so that any communication happens between the web browser and the web server has to be encrypted by this shared key. Now I cannot directly send this shared key to the web server without any encryption. Okay, so what the web browser does is once it generates a shared key, it encrypts or locks this shared key using public key, which means this shared key will be encrypted using public key. You can ask now, anyway, first the web server sent the public key information to the web browser before, and that is available through internet. It was not, encrypted or so. The hacker can get the public key and unlocks this share key. But here one tricky part is the public key can only be used to lock it. If you have to unlock it, then you have to use private key. So remember this is very important point. Now our shared key is encrypted using the public key. The one who is having the private key, that is red key, can only unlock it and get the shared key. Now when the web servers receives this shared key encrypted by public key, this will be unlocked using private key. The only private key holder here is web server. So the web server unlocks it and get the shared key. Now the web server has a shared key and the web browser has a shared key, no one else. So whatever the communication happens between the web server and the web browser now onwards will be encrypted using shared keys. So what I mean is, when the web browser sends any information to the web server, that will be encrypted and locked by shared key, and the same information when it reaches the server will be unlocked using the shared key. And when web server sends back the information, that will be encrypted using shared key, and as our browser has the shared key already, it unlocks or decrypts the information. This is how the communication between the web browser and the web server is secure. Okay, let us move on to second point, which means how our web server gets its certificate signed by certification authority. Now we'll see what is certified authority and how it is signed. So which is basically how the web server get its certificate signed from the certification authority. Okay, it is a normal process. The web server generates a certificate with the public key and the private key information, and it asks the certification authority that I have decided to use a secure communication. So I have created a certificate with the private key and the public key. Please sign it. Then what certification authority does is it says, I have signed it for you with my private key. Anyone who has my public key information can think that this particular certificate is signed by the trusted certification authority. So the next thing what happens is browsers request for the web server for some information, and the same cycle follows. Okay, this is how our web server gets its certificate signed from the certification authority. So next we'll see what is self-signed certificate. As I have explained earlier, so consider your application is still in the development environment, and you want to have a secure communication between the apps, different apps deployed in your web server, and as it is a controlled environment or inside your web server itself, so you need not have to get your certificate signed from the certified authority, because if you have to get it, then you have to pay for it. So we'll see how it works. So I'm taking an example of Gmail application and Google Drive. So these are the two applications deployed in my web server. Let's see how both communicates through HTTPS connection. Now the web server generates a certificate with a private key and the public key. And now we don't want to go for paid certified authority. So for that, what we can do is we can mimic that certified authority. What I mean is we can create our own certified authority inside the controlled environment, inside our web server itself, and we can consider it as a certified authority, so that communication between one application to another application, which is Gmail application to Google Drive application, secure. Okay, now what happens is we'll create our own certification authority with a private key and the public key. Then what happens? The usual follows. The web server says to that certification authority that I've created a certificate with a public key and private key, please sign it. Then the certification authority signs it. And next what happens is browser requests the web server, hey, I want some information. Then the web server sends back the certificate signed by our own certification authority. Remember, this is our own certification authority, which means that certification authority is not listed in the browser trusted certification authority list. So now it is not listed. This certification authority is created by us and it is not listed in the browser's trusted certification authorities list. Then what browser does is, I don't have information about the certification authority which you have sent, and I cannot have a secure connection. So as it is in a controlled environment, as I said earlier, and it is within our web server, then we can ask the web browser that please, this particular certificate is generated and signed by certification authority which is created by me. As of now, please trust this certification authority, which means we can add the certification authority in the trusted certification list in our web browser, so that whatever the communication happens next, the browser can think this communication is secure. So basically this is only for the development or in the testing stage. When your application goes to production, you must buy the signature from the certification authority to have a secure communication between the client and the web server. Okay, so this is how self-signed certificate works. Next, we'll see what is SSL, secure socket layer. Basically, to have a secure communication between the web browser and the web server, there are certain protocols needs to be followed. I mean to say, certain set of rules needs to be followed. So this particular protocol is called secure socket layer. So as you can see here, it's the standard technology or the protocol for keeping an internet connection secure and safeguarding any sensitive data that is being sent between two systems, such as browser and the server, or it can be between the server and the server, preventing criminals from reading and modifying any information transferred, including potential personal details. So this is just a protocol to have a secure communication between web browser and the web server. What is TLS? TLS basically is the improved version of SSL. More kind of a security is added into this, and it works similar as SSL. So this is what the TLS is. So now we have seen how HTTPS works, and what is certification authority, and what is self-signed certificate, and what is SSL, and what is TLS. Okay, so in my next tutorial, I'll be explaining how to add the certificate to any Spring Boot application and how to make your Spring Boot application a secure one. So I'll be showing you how to do that in my next tutorial. Please wait for it, it will be coming soon. And if you like this video and like my explanation, please subscribe to my channel and like this video. Thank you.